All right, so for homework number 2, our first problem number 319, it's asking for the length of triangle edges and then it computes the perimeter. Also, we have to make sure if the side lengths are valid. So, very simple code for our first one here. Please enter the lengths of the triangle edges. I have all three declared here, A, B, and C. We then use console in to read those inputs. And then here is my validation. So if A and B is less than or equal to C, then we know that is not a possible triangle. Or go ahead and account for all sides. So A and C, if that is less than B, or finally B and C, if that's less than A. So that accounts for all sides with our equation if of 2 needing to be longer than the third. So if any of those cases, we have our or operating here, if any of those cases happen, then it will see out invalid triangle side lengths. Please re-enter. Else, everything is okay, so we see out the perimeter is, and it's simply A plus B plus C. So that is it for that first problem. Our next one definitely gets a lot trickier than our first one. Uh, this is how I accomplished it. So we have two circles, so they will each have an x and a y coordinate. So for the first circle, x coordinate 1, y coordinate 1, radius 1. And then we're also going to need distance because that is part of our formula for figuring out our answers for what we're looking for. So we have all of these initialized. Then we're going to get our first circle measurements. So we're going to prompt the user to enter their XY coordinates and the radius for the first circle. So everything is relating to the first circle here, XY radius. And then same thing, but for the second circle, so XY and radius. Then we have our formula, which is distance is equal to the square root. I didn't use the PAL function. It's can be very slow at times or cause problems, and especially when it's only squared, it's just easier to multiply the two together. So it did wind up with a lot of parentheses, but nonetheless it works. So x coordinate 2 minus x1, and then it needs to be squared, so I have x coordinate 2 minus x coordinate 1. So those are multiplied together, and then we need to add the same thing but for the y's now. So y2 minus y1 times y2 minus y1. And then we take the square root of all of that. That gives us our distance between the two centers of the circle. And per the homework, we know that if the distance is less than or equal to the absolute value of radius 1 minus radius 2, then one circle is inside the other. I also went ahead and included, in case if you leave it just at that, it will always say circle 1 is inside circle 2, if that's how you write it. So what I did is wrote another if statement here. If radius 2 is less than radius 1, so we know that circle's smaller, then we know circle 2 is the one that is inside the other. Else, we know that 1 is the one that's inside circle. And then it also asks us to check for if they overlap, and it gave us a formula there as well. If the distance is less than or equal to the two radiuses added together, then they overlap one another. And because they're overlapping, we don't need to know, like, we don't have to specifically say 1 is overlapping 2 or 2 overlapping 1, like we did with the concentric circles, needing to know which one is inside the other. I thought that was something I stumbled upon while I was checking my work. All right, so for problem 4.27, this one is fairly simple if you know how to compute a leap year. So here we needed to see so I believe I had a little difficulty with the pausing, but we're going to roll with it. So on our third problem, we needed to list out all of the leap years. So the most complicated part of this was just figuring out these two formulas right here for me. We have the count, which is just a counter. And then everything else is initialized here. So it's for date ranges from 2001 to 2100. So for integer I, start at 2001, as long as it is less than or equal to our final year, and then our updater. So here, this line is the formula for finding a leap year. I had to look this up. So if I, which is our year, if it is divisible by 4, meaning our modulus would be 0, then it is a leap year. Also, if it is divisible by 100, it actually is not a leap year, but if it is divisible by 100 and by 400, it is a leap year. So we had to toss in some extra parentheses here. We had to get this as one section together with the and, so that way it accounts for all leap years. And then this line is what makes it have 10 years to one line, as the homework stated. So if, and then our counter is divisible by 10. We know there are 10 in a line then, and what it will do is it will see out in line, so it will cause it to go to the next line. And then we still want to know what that year is. We still want it to be printed, so we will also print that year and then our space, and then update our counter. Else, if it isn't need for a new line, we'll simply just see out the year, a space for formatting, and update our counter. So that very short code, but these two right here took me a while to figure out. But once we did, nothing too crazy. Now our last one took me a little longer. I think it was mostly because I couldn't decide which way to cut this. Thought about doing case and switch statements. Thought about enumerating things, but really the easiest for me, I decided to use some arrays, and that made it fairly simple. Just a lot of typing for those arrays. So we need our year, which is user input, the first day of the year, which is user input. And the problem asks us to output the first day of each month in said year. So I included an array for all of our months, January through December. And then I had a day array, which is Sunday through Saturday. And then I found that the easiest way to keep up with the days in the month so we could figure out what day the first day would be on was to also make another array, and included 31 days for January, 28 for February, 31 for March, so on and so forth. So we ask for the user to enter the year. So if it's 2020, they would type that in. Then here is our console end statement. Then please enter the first day of the year, 0 for Sunday, 1 for Monday. So they're using an integer to see in the day. And we read that in. And from our last problem, we now know how to compute if that year is a leap year. And if so, we need to change this 28 that was stored for February to 29, because there are 29 days in February in a leap year. So simple statement here. We already know our formula, so that went a little faster. And then finally, we just have our for statement to loop through all the months and see out the first day of each month for that year. So we'll start at 0, so long as it is less than or equal to 12, because we want to, or well, actually it should be less than 12. I even caught myself there. So as long as it is less than 12, we could have a potential overflow. I think it would have been okay, but I had tested and it was fine. But as long as it's less than 12, because we're going through each month, that is what we need to keep track of. There's nothing after December that we go into another year. So that was what I chose to use for this for statement. And then we're going to see out the day array and day. So that will give us, for our first user input for January for 2020, the first day of the week, January 1st was a Wednesday. So the user should have, if it was 2020, should have put in a 3. So day would equal 3. and we would go to the third instance in the day array. So that would be Sunday, Monday, Tuesday, and then Wednesday. So it would see out Wednesday, comma, space, and then the month, which is 0. We're using our index here. So that would be January. So it would say Wednesday, January 1st, and then our year 2020. And then following this is how we update. This is how we find out what day of the week the first day is on. So it looks a little more complicated because it is using the arrays, but it's simply the day. So Wednesday was a 3, so 3 plus, and then wherever we're at in our number array. So January has 31 days in it, so 31 plus 3 is 34. And we use the modulus operator to divide it by 7, and we know whatever is left over is going to be the day of the week for the following month. So we will update day accordingly. So that way, the next time it will say day array with our new day. I believe for February it's Saturday, something like that. And then our month array has been updated because it's using the index. So it will say February 1st, 2020. Also, 2020 is a leap year. So our program will have known to have changed the number of days to 29 in February. So that is our final program, and that does it for homework 2.